Hi folks, welcome to 1 Minute Math. Today we're doing the topic of slope, and in this video we're going to do the full-length explanation of the slope of a line, an Algebra 1 concept talking about lines graphed in the plane and measuring their slope or calculating their slope. If you're looking for the short little 1-minute clip that just briefly goes over this explanation, you can find a link in the comments. But this will be the longer video explanation. All right, slope in the Algebra 1 context, well, really in any context, slope is a measure, a numeric measure of how steep a line is. It's essentially a fraction that measures the vertical change divided by the horizontal change, or I call it often the over and upness, how far over, how far up, and we divide those to make a fraction, and that quantity represents the steepness of a line. We'll come back to the visuals here on this slide when we're doing some computing, but you can just see, like, we're talking about taking 2 points on a line and measuring how far do I have to travel to get to the right or left, and how far do I have to travel to get up and down. I'm going to divide them. Okay, all of these explanations we see here are talking about fractions or divisions or ratios. By visual inspection, we can tell a few things about the slope of a line. If I'm looking at a line that goes uphill as I'm traveling from left to right, that's a positive slope. If I'm looking at a line that goes downhill from left to right, that's a negative slope. If I'm looking at a line that is completely horizontal, sometimes people look at this and they're like, oh, look, it's a straight line. They're all straight lines. This is a straight, flat, horizontal line that would have a slope of 0. And if it's a straight vertical line, that has an infinite slope, or we could say that the slope is undefined. And we'll come back to these again as we do more examples. You'll see the difference between those kind of categories: positive, negative, 0, and undefined. Slope is a fraction. Sometimes it doesn't look like a fraction. Sometimes it looks like a whole number, and we'll be able to put that number over 1 to create a fraction. But in the fraction that represents slope, the top number represents the vertical change, and the bottom number represents the horizontal change. So let's just take this red line, for example. If I go from this point right here to this point down here, I had to move left and right 2 and up and down 1, 2, 3, 4, 5. Vertical change divided by horizontal change, the slope of this line is 5/2. And now what if you're saying, hey lady, what if I didn't choose those exact same 2 points that you did? Am I not going to get a different number? And I'll show you why you're not. Let's just say for giggles that you picked this point and this one way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. If this is an exactly straight line, I will get a slope no matter what 2 points you choose. I will get a fraction. Like 10 and 5 are not the same number, but when I divide 10 divided by 4, this fraction will reduce to be the same fraction that I got using other points. Isn't that cool? If you don't get the same number no matter what 2 points you use, it's not a line. So now let's compare that to this one here. I've chosen these 2 points on purpose, or these 2 lines on purpose, because you notice on this blue line here, I've got a vertical change of 2 on a horizontal change of 5, and I want you to notice the difference between how these lines look. Same 2 numbers, 5/2 or 2/5. Do you notice how 5/2 is a steeper line? The red one is steeper. Vertical change is greater than horizontal change. 5/2 is 2.5. That number is greater than 1, and I have a steeper line. That's not a coincidence. And this other one, 2/5, which is 0.4, if I look at it as a fraction, that's less than 1, and I have a not so steep line. I'm going to say flat. Okay, so the larger the number is, the steeper it is. The closer the number is to 0, the flatter the number is, or the flatter the line is. All right, when I'm talking about calculating slope, there are 3 different ways you can calculate a slope or report a slope. If you're looking at a line, you can look at a graph and calculate the slope. You can be given 2 points and be able to calculate the slope, or you can be given an equation of a line and from that determine what the slope of the line is. These are 3 things that your teacher will probably ask you to do. If I'm looking at a graph, I'm going to do exactly what I just did in that last example. Pick any 2 points and count how many spots over and how many spots up. Up divided by over. We sometimes hear the phrase rise over run, like the up and down, running and rising, rise over run. It's the vertical divided by the horizontal, the change in y divided by the change in x. That triangle means change in. So not just the y coordinate. Notice how I never care. The coordinates of this point are 3, 5. I do not care because I'm not using the 3 and the 5. I'm using a change in the coordinates, okay? And again, this would be another example where if I used other points, if I used this point and let's say this point over here, I've gone over 3. 6, 9, and up 3. If I called that 3 over 9, I could reduce it to 1/3 and get the same number. How about this guy? Now, I'm looking at a vertical change divided by a horizontal change. And I'm thinking we always go left to right in math, starting on the left and going to the right. So let's just pick a point here. This is going to be my first point. And this down here, he's going to be my second point. It's often easiest if you use points that are close together. I have a horizontal change of 2. And my vertical change is -3. To get from the first point to the second point, I went down. Numbers get a negative sign on them if you go left or if you go down. So whether I think of this as going down and to the right, or maybe I was thinking, this is my first point and this is my second point, and in that case, I have gone up 3 and to the left 2, I'm going to get a negative answer. This is -3/2 or -1.5 if you like it in decimal form. Same deal over here. I'm going to get a negative answer for my slope. And this is why negative slopes are lines that go downhill. All right, so now let's look at what happens if I'm not looking at a picture of the line. I'm just given 2 points numerically. We should be able to do all things in math numerically, graphically, conceptually, algebraically, right? That's a complete understanding of a math concept. So here I'm going to do the numeric version. I'm not looking at a visual picture of the line, but I'm given points that the line goes through. So the question might say something like, find the slope of the line that goes through these 2 points. Here's my formula. Slope is y2 minus y1 over x2 minus x1. Hopefully this makes sense to you based on what we just did, that if I have 2 y coordinates and I'm looking for the vertical distance that the line has traveled, I just have to subtract one from the other. Now, what's this business with the 1s and the 2s? Well, you notice how I have 2 points. So I can't just say this 2 is x and 8 is y, because like 4 is also x and 9 is also y. So I put the 1s on here as subscripts. It's not x squared. It's not y squared, it's not x to the 1. They're subscripts. They're just like last names on the name of the variable so I can keep them straight. I have a 1 on this x and this y because this is like 0.1 and this guy's 0.2. Okay, so I'm just going to follow my rule here. Y2, which is 9, minus y1, which is 8, divided by x2, which is 4, divided by x1, which is 2. Do a little subtractorino, and we got a slope of 1/2. Bam, easy peasy. All right. And again, it's not a bad idea to write out x1, y1, x2, y2 until you feel really comfortable doing this quickly, because it's real easy to accidentally subtract 9 and 4. But I'm not comparing 9 and 4, I'm comparing 9 and 8. I'm comparing y coordinates. Let's try this guy down here. Okay, don't be afraid of big numbers here. I've got x1, y1, x2, y2. I'm just going to follow my rule. y2, 206, minus y1, 356, divided by x2, 207, minus x1, 107. All right, now you can check my math if you'd like to here. You can grab a calculator if you would like to actually check my computation. Math is the thinking that we're doing. Computation is just crunching numbers. 207 minus 107 is 100. And my answer is -150 over 100. Hopefully your math teacher thinks, that's not a great answer. I'll give you half credit for that. But for your full answer, you should really simplify it. We want to see this as a simpler number because it's simplifiable. The first thing I'm going to do is just divide the top and the bottom by 10, and I get -15 over 10. And I notice that both of those numbers are divisible by 5. So I'll divide the top and the bottom by 5, and I get -3/2. That's my slope. Now, sometimes things happen. We're not going to go too far away from our rule, y2 minus y1 over x2 minus x1. This formula is always reliable, but sometimes some funky things happen, and let's see what happens when they do. Okay, y2 is 5, y1 is 5, minus x2 minus x1. All right, 5 minus 5 is 0. It doesn't really matter what this thing is at all on the bottom, but let's figure out 34, take away -12. It's like adding 12, 46. Hopefully this is something you're familiar with, but let me give you a quick trick. Dividing with 0 is always a little scary. Sometimes it's 0, sometimes it's undefined. If you see 0 over a number, let's just pick 3. Zero over a number is zero. And I think of it this way. When the zero is over the line, over makes an O, that's zero. Okay, this equals zero. If I had a number on top of zero, if I had 3 divided by zero, when zero is under, it's undefined. I'm going to give a shout out to another YouTuber, Frank Ives is a great math channel, Math by Fives. He tells this cute little story how Humpty Dumpty, you know the story of Humpty Dumpty? When Humpty Dumpty was sitting on the wall, he looked like an egg. He was like a zero, zero. When the zero is on top of the wall, it's a zero. And then when Humpty Dumpty fell off the wall, he was so unrecognizable. He was undefined. All right, so there's another way you can remember it too. But the zero, when the zero is on top, it's zero. When the zero is underneath, it's undefined. You can't divide by zero, but you can divide zero by other numbers. So I've got zero over a number here, and this gives me a slope of zero. And check out my video about graphing lines if you want to see what a slope of zero does to the picture of a graph and how it looks. On this next one, x1, y1, x2, y2. I've got y2 minus y1 over x2 minus x1. I don't even care what this number is on the top because I see I'm going to get a number divided by zero. We can't divide by zero. This slope is undefined. Your teacher might say that the slope goes to infinity. That's not untrue, but undefined is kind of like the catch-all. That's a nice way of covering your bases. You know, it's not going to be wrong if you say the slope is undefined. All right, very last thing that we can do here with slope is calculate or find the slope if we're given an equation. Most of the time, your equations are going to be given to you in y equals mx plus b form. And then slope is just the number that is attached to the x. It's that easy. So right here, I've got this 7 over 2. He's attached to the x. That's my slope. M is 7 over 2. Up here in this purple one, it looks like it's going to be 3 if I think about the equation y equals mx plus b, but notice how the m is always attached to the x. It's not the number that comes first, it's the number that's attached to the x. And I got to take the negative. When a negative comes before a number, it belongs to that number. So my slope in this top line is -5. Now in this bottom one, this is another little bit of a scary beast here because I don't have the equation in y equals mx plus b form. But I can get it there. I'm going to do a little bit of algebra here and rearrange my equation. I'm going to subtract 2x from both sides. I'm going to divide everything by 5. That means I have to divide everything by 5 over there on the right. So the left becomes y, and the right is going to be -2/5 x plus 14 divided by 5, which is 2.8. You can check my computation on that if you'd like. The slope is the thing that is attached to the x, -2/5. So the takeaway here is that the slope in this equation form, the slope is the thing that is attached to the x when y is alone on one side of the equation. So you've got to take that first step of making sure that y is alone on that side of the equation. That's it for slope. I hope you found this helpful. Be sure to check out my other videos, and thanks for watching.